Hello and welcome to episode 22 of Daryl Show Your Work. In this episode, we'll be covering some common vulnerabilities found in scripting or in coding. Just to give a high level overview, we'll be discussing the pickle method in Python. We'll be discussing XML vulnerabilities, specifically when dealing with XML parsing, and then we'll be going through the XML external entity. All right. So to get started, we're going to get started with the pickling method within Python. So the pickle method is used to serialize and deserialize Python objects. So serialization is the process of converting data objects or structures into streams of bytes for storage or transmission over a network. A common example is sending user data to a database. All right, and then the reverse process is known as deserialization, which involves reconstructing the byte stream back into objects or structures. An example of deserialization would be retrieving user data from a database and then modifying it. So let's start with pickling. I'm going to give an example of what that looks like. All right, and then we're going to talk about the vulnerabilities of with the whole pickling serialization deserialization process. All right, so first I'm going to show you what the pickling serialization process looks like by first starting up Python, and then I'm going to use the version 3 interpreter. All right, so now I'm going to write a command to I'm going to import the pickle module. Okay, all right. Next, I am going to create a dictionary file where I'm going to be defining some objects here. So I'm going to start by writing a test equals a curly bracket, single quote, and then I'm going to say first name. All right, then I'm going to end that quote, and then a colon, and then I'm going to define first name as John. Right, and then I'm going to define the last name as Doe. All right, in curly bracket. All right, check out my syntax here to make sure everything is all right. All right, looks like we should be good to go. All the brackets and quotes are closed, so I'm gonna hit enter. All right, so then the next thing I'm going to do is create the output file in which the pickle data will be stored. So I'm gonna write out file equals open, oops, parentheses, test underscore file. All right, then put a comma, single quote, WB, single quote, and then in parentheses. All right, give me a second here. I need to turn something down. All right. Okay, so that is my output file. And so next I'm going to write a pickle dump file, which is going to store the dictionary values to the actual output file. All right, so I'm gonna say pickle dot dump, say parentheses test. All right, so I'm putting my dictionary file in there, and then I'm gonna put my output file in there, which is out file. right, close parentheses. All right, hit enter. All right. And then to end the whole serialization process, I'm going to close the file by saying out file dot close parenthesis. All right, so that is basically how the pickle method is used to serialize a file. Now let's unpickle this or deserialize it. So to begin doing that, we're gonna so we put our dictionary file, which is test, in this pickle file. So let's try to then retrieve it by again unpickling it, which is the deserialization process. So I'm going to start retrieving it by opening the file that contains the data. So I'm going to go to pickle underscore file equals. Let me put some space in between that. And all right, then we're going to say test underscore file RB and then close parentheses. All right, just checking my syntax here to make sure I'm good. All right, hit enter. All right. All right, now we're going to actually enter in the command to begin the deserialization process now that we have that file open. So I'm going to write new underscore test equals pickle dot load parentheses pickle underscore file. All right, close parentheses. All right, enter. All right, and then let's see. We're going to print now the deserialized object here. So let's see if it worked. So I'm hit print, new file, new underscore test. All right, in parentheses. All right, let's see if it worked. All right, and there's our original test object that we defined up here, our dictionary file. So we were able to successfully to unpickle that or to deserialize what we serialize with the pickle method. All right, so that's an example of the serializing and deserializing using the pickle method. So now we're going to go into the vulnerabilities with it. Hold on, excuse me. Got to put the parentheses there. All right, now we're out of Python. All right, so I am going to open my web browser here. We're going to go to a mock site. Nah, hold on. Okay, there we go. Okay. All right, let's go back here. All right, so I'm gonna open up my Firefox browser. All right, so we're gonna navigate ourselves to HTTP / and we're gonna go to 192.168.1.101, and then we're gonna be utilizing port 5000. That's where it's housed. All right. So now we're at the mock site. So we're going to be experimenting a little bit with Pickle and exploring some of the vulnerabilities. All right, so I'm going to switch to a directory here in my terminal that's going to actually pull up the source code to this website. So I'm going to do change directory, documents, lab dash code vulnerabilities. All right. Okay. All right. We're in the directory, and I'm gonna just show you the files that we're going to be working with here. So we're going to be working right now with this pickle underscore vuln Python script, which is the source code of the web page that we were just looking at. So I'm gonna say nano. I'm open it up in a text editor. So nano pickle vuln py. All right. So just to kind of describe what you see going on here, this script demonstrates that the data in the first decoded is first decoded from the base 64 and then unpickled using pickled load. So again, this is where it tells us that it's using base 64 to encode, and then where is the part with the pickle loads? Pickle loads. It should be somewhere in here, but basically though, um, um, again, the script is demonstrating that the data is first decoded from base 64 and then unpickled using pickle loads. To exploit this implementation of the pickle module, the payload must first be pickled with pickled dot dump and then encoded to base 64. So we're going to see what that looks like. So I'm going to exit out of here. I'm just hit Control X, and I'm going to show exactly how that worked. I mean, I'm going to go back a few directories here to show us what that looks like. Let me see. But then like me going back. There we go. Okay. All right. So we're going to be working with a file called exploit python. All right. So I'm a cat. And we're going to take a look at some of the vulnerabilities in here. Okay. So if you notice that the default command in here is who am I. So that just basically tells you what user you're currently logged in as. Now if we look here at the command sys argv, this line is used so that different payloads can be pickled without having to change the script each time. All right, and then we go down a little bit looking here at where it says reduce. The reduce method in a pickle module specifies how objects should be serialized and returns a tuple that describes how the object should be reconstructed during serialization. The tuple typically includes a callable, usually the name of the class to invoke, and the arguments to pass to that callable. So in this instance of the reduce method, right here, the OS system, and then where you see next to it where it says command, this is the tuple in which the OS system is the callable and the command is the argument passed to the callable. All right, so let's see how this works, and I'm gonna show you what the exploit looks like. All right, so I'm gonna do Python 3. All right, then I'm gonna tell Python what file I want to work with, exploit.py. All right, then who am I? Okay, so we know that who am I is a default command that this exploit.py what it usually works with, what it works with. So how it should work, it should then give us some sort of this message, whoever we are or whoever it come back as we're logged in as, it should come back giving us a base 64 encoding of whatever that clear text is. All right, and there's the base 64 encoding. So base 64 is calculated a bit differently than an encryption method, and it's far more easier to crack in an encryption method. So as far as using a method of obfuscation, it's better to use a encryption method, a strong encryption method over encoding, because encoding can pretty much easily be broken, which I'm going to show you here in a minute. So I'm going to copy everything from the G to the equal sign here. All right. And then I'm going to go here to pickle, to the pickle portion of the website. I'm going to plug this encoding in. All right. And we're going to see what happens when we send that. Look, so now we got to clear a clear text a response as far as what to the who am I command, which is Ubuntu user. So it just proves that this serialization method was pretty weak and easy to crack. All right, so just some takeaways from this. Some pickling best practices. Never unpickle data from untrusted sources. There's a serious risk of execution of arbitrary code with the privileges of the unpickling process. All right, then transmit pickled data only through encrypted network connections to prevent malicious actors from intercepting, altering the information during transit. So think of like a man in the middle attacks. All right, then utilize cryptographic signatures to sign the pickled data, enabling the recipient to verify the information that has not been tampered with. So again, think of like hashing, like a one-way encryption algorithm. Okay, so something that has non-repudiation associated with it. And then lastly, consider switching to a safer serialization format such as JSON. So JSON is Java based, and it's a lot more secure than the pickle method. All right, so the next thing we're going to be moving on to, that's about all she wrote as far as us covering pickling. So the next thing we're going to go to talk about is XML parsing. And just as a reminder, what XML is, it's a human and machine readable markup language used primarily for encoding and structuring documents. All right, so we're gonna on our site here, we're gonna go back to the main page, and then this time we're gonna go to the XML portion. All right, and so to basically show you how XML usually works here, I'm gonna write a quick XML script. So I'm gonna write test, and I'm putting inside of it testing, and then close tag test. All right, I'm gonna hit send. All right. See, in the output, it just pretty much gives us whatever it is that's in those tags, which again was testing. All right. So I'm gonna go back in the terminal. Now we're going to I'm gonna go back into the vulnerabilities directory, and we're going to pull up actually the web page source code for this web page now. All right. So cd And then, in fact, matter of fact, I'm gonna just go through my history and go back to the vulnerabilities. And then, let's see, we at lab, so I'm gonna just do. And then like that, you're gonna really make me write this whole thing out? Okay, let me see. Well, all right, so I'm gonna just do this. Code. Let's see why I didn't like that. Oh, well, I gotta put CD, don't I? All right. That's why syntax matters. All right. So let's just get rid of this. All right. Still saying okay. Well, let's see. Let's see. Yeah, it's right there. Okay, I'm not sure why it's. All right, let's just write this whole thing. Write the whole thing out, and that should take us right to it. I'm not sure. Okay, there we go. We're back in. Okay. All right. So, all right. So then I'm gonna go back to our list here. All right. So now we're going to be working with the XML vulnerability Python script. Again, this is the source code to the web page that we were just looking at. So I'm gonna cat that so we can take a look at what's going on inside of the source code. All right. So starting from the top here, where it says from XML.dom. So XML.dom set of modules is used to create and read document object model trees from the XML. The code checks whether any data that's been passed to the backend from user endpoint. All right, and then moving on to the next line here. An XML .sax parser is initiated to create a sax XML reader object. And then the line under that, an additional line adds the feature of parsing external entities to the reader object. All right, so moving down here to where it says doc equals. So the parse string method accepts parse events from the sax and converts them into a DOM tree. All right, so this is all leading to what it is being what's going to be exposed to, and that is an XML external entity. All right, so this is an attack that exploits weakly configured XML parsers that handle input files containing a reference to an external entity. Entities define shortcuts to special characters that can be referenced by XML files. All right, so think about a lab I did a few videos ago dealing with file inclusion attacks, local file inclusions, remote file inclusions. This is of kind of like of the same type of ilk, the same type of similarity, and also it's exploiting too the use of special characters within the script or the code. So I'm gonna show you an example of what I'm talking about here. All right, so I'm gonna go back to XML here. And so let's clear this out. And I'm gonna write another line. I'm gonna write another line here, but this time I'm gonna say author, and then the middle, I'm gonna define the author as John, but I'm gonna put a special character in it. I'm gonna say greater than Doe. And then I'm gonna close this tag. All right, and let's see what the output we get. See, so it's allowing this special character to be to be displayed, and that's not good because it's not good in terms of input sanitation, and the type of attack that I mean, this could actually lead to all types of attacks because it could lead to executable files being launched in here, since a lot of them require the use of special characters within their scripts to run. But I'm going to put in another. I'm going to paste in, because it's rather long, another another set of code here for it to run, and let's see if that works, since we see now they allow special characters, and that also it allows, it includes the inclusion of other instructions. Okay, so paste that in there. All right, so what we got going on here, let me go back to the top. So I'm basically, in my first tag, I'm defining what programming language I'm using, and then I'm saying what version. All right, and then I'm defining I'm defining myself as root. All right, I'm putting that here, and then I'm telling it to grab a system directory. All right, and then I want it to show me the directory of the password file, which actually is going to show the user all the usernames that have access to this particular system or a portion of the network. And then I close my root tag here again, just giving myself doing this as root. Okay, so basically when I hit send, what should happen is I should then be able now to see the contents of the password file within the local directory. So let's see if that works. And it does. And so this is problematic because this allows an attacker then to enumerate users on a network. So what they could do is they could just copy this and then put it in a greppable format, or put it in a format that's easily readable for them, and just have a copy of all the users that are here on this network, and then know which profiles to go to it, in terms of trying to find hash dumps. And it takes half of the workout as far as trying to figure out usernames and passwords to deduce when trying to, let's say, trying to brute force a system. Okay, so now, okay, so I guess the next question would be, how do we stop this? How do we prevent this from happening? So there's some mitigation techniques out there, and we're going to focus on one in particular. And so we're going to go back to our source code, and I'm going to open it up with for my text editor, nano xml underscore bone dot py python. I'm gonna open that up. Okay, hold on. Nope, something went wrong. Okay, let's exit out of this. Let's see, what didn't it like about my syntax here. Forgot my N. Sorry about that. Okay, all right, we're in the file. So the culprit here in the code that's causing things to go wrong right here is this feature underscore external jest, and it's set to true. So this is what's allowing the external entity vulnerability. This is what's causing it. It's being caused by this, and it's allowing the inclusion of pretty much anything that an attacker or somebody wants to define. In this case, it was the inclusion of the Etsy password file from the command line. So by this being set to true, you could define pretty much any place within the excuse me, and by defining your role as root, you can pretty much choose any directory that you want to run from that command line, and see what the contents of that, to have that outputted to you when you hit send. All right, so I'm going to set this to false. All right, and then another thing that that could be done too. You could just straight up just take this whole line out of here. But in this example, we're just going to set it to false. All right, so I'm gonna exit out, and then I'm gonna hit yes. I want to save it, and then enter. All right, so something we could do just to check to see if to make sure that this is set to false moving forward, I could do a grep and then false, and then specify the file that I want to check for that in. Python. All right. So again, we know when we say grep that we're telling Kali that we want to look for a particular term, and we define that next to grep. And in this instance, we're looking for false to make sure that that's in our script here. And then we're defining the script that we want to check that again. So I'm gonna hit enter, and we can see here that it brought back the part of our script that's been set to false, which indeed is the feature external jest. So that brings us to the end of our video. So we went through serialization, deserialization, using the pickle method, and then we explored some vulnerabilities within that, and then we also looked at the XML, and looked at to see what are some XML parsing in particular, and then looked at some vulnerabilities that could be found there, as far as the XML external entity, which is very similar to your file inclusion types of attacks. And then we covered some ways that we can mitigate against that, and also going back to the pickle, also discussing some ways that some best practices when looking to serialize and deserialize files. All right, so please like, share, subscribe, and most importantly, show your work. And until next time, take care of yourself and God bless.